Domain and range. So domain, remember, is the x values and range is the y values. So it's already noted here for you. We'll use the less than symbol for if there's an open circle, and we'll use the less than or equal to sign for the closed circles. So domain is our x values. So here we always do from left to right. For y values, we always do from bottom to top. So let's look at, here's our leftmost value. And I look down and that's at -4. So that's the first number I write. We have an open circle, less than, we're doing x's. And then another less than, this is a closed circle, so that's less than or equal to, and that x value is 1. We're going to do the same thing with our y's, starting at the bottom, working our way up. We got, this is the bottommost value, and I look at the y-axis now, that's -3. We got a closed circle, so less than or equal to. We're doing with y's now, go all the way to this one. That's a +4. It's an open circle, so it's a less than symbol. All right. The graph of the part, this is how you're going to see them worded. The graph of part of linear G is shown on the grid. Which inequality best represents the domain part shown? So we're looking for x. So looking at my answer choices, this one has an x, this one has an x, this one has a g of x, which is another way of writing y. So those can't be our answers because we are looking for domain. So let's go left to right. This is -9, and this one is 2. Okay, both our answers have those. So, and then we need to check the symbols. This is an open circle, so it needs to only have 1. That one has 2. This closed, so that has to have those 2 symbols. What is the domain and range? All right, for our quadratics, we always had the arrows on the end of them. So then domain is all real numbers. All real numbers. Sorry, I put that. That's the symbol for all real numbers, all real numbers. So then let's look at our y's. Remember we wrote y greater than or equal to or less than or equal to. We were using greater than or equal to when it goes up and less than or equal to when it goes down. So this one goes up, so we're going to use greater than or equal to. And then we look at the bottom number, bottom y, -6. It's also, remember, the y value of your vertex. All right, even though this one curves and it's part of a quadratic, it stops. And we can clearly see it stops. So our domain is not going to be all real numbers. We're going to do just what we did here for our linear. So domain is the x value. So we start still left to right. From here, our x value, first x value is -3, less than or equal to, because it's a solid, it says the rightmost value at 2. It's an open circle, so we have just the less than symbol. All right, range, we go from bottom to top. So not from this point, but from the very bottom of it, -7. That is included, since it's on the line, then it's a less than or equal to y. And then we go all the way up to the top. This is the last y value, and it is less than or equal to 2. All right, what is the range of y equals -x² - 2x + 3? range is our y values, so I can mark off A and B. And then I can come graph this. Delete this off of here. Menu 3, 1. We've got negative x squared minus 2x plus 3. And it is facing down. So we remember we used the less than symbol. So this one has the less than symbol. This one has greater than symbol. Let's go ahead and double check that it's less than 4. If I look 1, 2, 3, 4, my y value there is positive 4. The daily cost of hiring a plumber, y, to work x hours on a project can be modeled by using a linear function. He charges a fixed cost of $80 plus an additional $45 per hour. The plumber works a maximum of 8 hours. For 1 day of work, what is the range of the function for the situation? So we need to know how much money, what's the least amount of money he would make, and what's the most amount of money he would make. So he charges fixed cost of $80 plus 45 per hour. So that means that how many hours he works, we're going to charge $45 for each of those hours. $80 he's just going to make, period. Okay, so let's look at our answer choices first. We're looking for range, so that's y's. We know that he's charging $80 no matter what. He's charging $80 no matter what, so 60. We know at minimum he's going to make this. All right, a golfer hits a golf ball from the tee that is 6 yards above the ground. The graph shows the height in yards of the golf ball above the ground. The quadratic function of x, the horizontal distance in yards of the golf ball from the tee box. What is the domain of the function for the situation? Domain is x. So what is the leftmost x value? And what is the rightmost x value? 0 to 230. A student rode a bike from school to the recreation center. The graph shows the student distance in miles from the rec center after riding the bike for X minutes. What is the range of the function for the situation? So range is y values. So our bottommost y value is 0, and our top y most value is 9. It says all real numbers greater than or equal to 0 and less than or equal to 28. No, that looks like that's the domain. All real numbers greater than or equal to 0 or less than or equal to 9. Yes, that's what we said it was, 0 to 9. C and D are wrong. It says all real numbers less than or equal to 28. No. And 9.